Basically, it's a free mobile game engine that's available for Android, obviously, but also iOS and Tizen. I'm Joel from Eenwyk. I'm a field application engineer that works at Havok, and I basically do evangelisty stuff, and I still get to program, thank God. But yeah, so let's go ahead and get started. Basic agenda of what we're going to go over. Who is Havok? Hopefully you guys know. There's a pretty good chance you don't. Havok is the company I work for. What is Project Anarchy, which is the mobile game engine? Why is it free? It's totally free. Confuses people. What exactly do you get with it? And obviously I'm going to show you guys some demos as well, because demos are cool. So who is Havok? We've been a middleware leader for about 15 years now. We started in 1999. So bleeding edge technology, we're fully cross-platform. This has been a goal of ours from the very beginning. So we've been on PS2, GameCube, all the things. And now, of course, Android, iOS, and Tizen as well. And still have things like Vita, and all the things. So we've games that, and not just games, but products that have shipped with our tools or middleware solutions have been over 500. You might have heard of some of them. Things like Assassin's Creed and Halo and all those games. And we also have offices all over the country for support reasons. So just a quick history of who we are. We started way back in the day, and if you have heard of Havok, you've probably heard of our physics engine solution. So that's what we developed back in Dublin in '99. And then we added an animation solution for doing animation blending and animation compression. Then we added Animation Studio for doing creating state machine blend trees. And then added a clause solution, destruction, which was built on top of our physics core, AI solution for generating nav meshes and doing path queries, script, which was actually a product, a Lua VM that was created primarily for consoles, so a lot of 360 and PS3 optimization specifically for that, since on consoles you can't actually have a JIT. And then in 2011 we purchased a company called Trinergy, which has been actually around for a long time now, and Vision is actually a full game engine, and then since 2011 until now, we've been integrating all of our products into that game engine. And that's the primary thing we're going to be talking about today. So what is Project Anarchy? I've said this a million times. Complete end-to-end game engine for mobile. That includes iOS, Android, and Tizen. And bundle contains a few things. The Havok Vision engine, which is basically the game engine, includes the world editor and the script editor and all that sort of thing. It includes our physics, Havok Physics 2012, Havok AI, Havok Animation Studio, and also Fmod for running sound on these different platforms, and Intel's GPA, which is a graphics performance analyzer. So we bundle all these things together. The idea is we're giving you all the tools necessary to make a fast, performant, graphically enticing game. I'm going to show you guys a quick demo here, and there may or may not be sound, so, or it could be really loud. basically foreshadowed a lot of the things I'm going to be showing you today. First off, again, it's completely free for mobile development, and you develop using a PC. One of the big selling points for this engine is you have full C++ access for all of the different products that are bundled with it. So you're pretty much guaranteed not to run into any roadblocks because you're not limited by an interpreted language. Our toolset, so vForge, which is our world WYSIWYG editor, is actually built with C#. So we actually have a manage layer in between to communicate from C# down to C++. And you can use C# to extend our toolsets, maybe add a new panel or integrate with some other tool. But obviously not everyone wants to use C++ all the time. I think C++ is great, but it is a slower iteration time. So with Lua scripting, you can prototype your game or actually even ship a game, because Lua is actually quite fast, and we include a full integrated debugger as well. So you can actually set breakpoints and look at global variables and multivariables and all that good stuff. And we do have comprehensive documentation. Remember, this engine has been around for a really long time, so the documentation is actually very, very complete. And it includes full game samples as well. Actually, the game that you see over here is actually called Anarchy RPG, and if you go on Google Play and the iOS store, you can get this game for free now. But all of the assets, all the models, textures, C++ code, everything is included. And this is just one. We include many, many samples so people know what to do. And as far as like an upgrade path, because there is potential for upgrades, if you make a lot of money on Android, which we hope you do, if you wanted to then take it over to Steam or something like that, then you could buy a Steam upgrade pack. Or you could purchase more source code with our Pro version, or get dedicated support. But what is provided here is by far enough to get you going. So why is it free? Part of it is we want to empower indie developers, those smaller teams. Traditionally, Havok has pretty much targeted really large studios and AAA games. So now we wanted to find things, pretty much the first time we've done this in Havok's history, where we actually target smaller studios and indie developers. And obviously we also want to teach students how to use our tools early on in life, so that when they get into the industry, they can use those same tools. And it's also part of our parent company, Intel. So Havok is actually owned by Intel. And Intel has this huge drive to make mobile better. There's the x86 motivation too, so they want to be able to push the hardware that they're making as much as they can. So this helps everybody, because they want more people to create great games, and we want that as well. As far as the community, we do have an active forum now, and it's been growing a lot. A lot of people it's almost become self-sustaining at this point. Me and a number of my coworkers, we still patrol on the forums to make sure that people's questions get answered, but it's already starting to be self-sustaining. We have a full questions area. If you know Stack Overflow, kind of the same thing. We also have an ideas section. We do listen closely to feedback from the community, so if you guys have feature requests or ideas, put them on there. They get upvoted. We actually do look at this and influence our roadmap because of this. We also have courseware, so full tutorials. A lot of people don't know what Project Anarchy is. Frankly, our competitors have been around for a lot longer, so people know them. So we created a bunch of tutorials so that people could go from not knowing anything to actually being able to create a game, as well as video tutorials. So jumping back into the tech, this is what I'm more interested in. Again, we have a versatile component-based C++ API, which is completely accessible to you guys. And by component-based here, I mean it's an entity component-based model where you have entities that exist in the world, and components or behaviors that can modify those entities. I'll show you guys some examples of that in a bit. We have a full WYSIWYG level editor called vForge. An asset management system. This is critical because you have textures and models, and depending on which platforms you want to deploy to, you could have PVR or ETC texture format. So our asset management system says, give us any texture that we can understand, and we'll automatically convert it for different platforms, or stretch and scale them down, or do that sort of thing. We also have a very flexible plugin framework, so you can easily extend not just the editor itself, but also the game code that you create actually runs inside of the editor too, so you don't have to actually deploy it to the device. You can just press play in the editor and see your C++ code running. And the plugins that are included with vForge, we include all the source code for that as well. So if you want to integrate with some other third-party technology, it's very easy for you to do that. And as far as getting the data, like assets, like animations or models, into the engine itself, we have export plugins available for 3ds Max and Maya. And we also do support FBX format, so you can convert, because we support FBX, that means Blender, Modo, all of those work as well. And we also have multi-user editing. So we actually have an integration with Perforce. And Perforce and Git are now really closely bonded together, so it's very easy to use one or the other. And because of the way we formatted our data, so we actually separate it by layers, you can work on a team of 2, 10, 50, 100 people working on one scene at the same time. We also have a Visual Studio integration for Android, so you can just press F5 and it automatically creates an APK and deploys it to the device. And if you have any breakpoints, you can use GDB directly inside of Visual Studio, so that's kind of convenient. And some tools that we include, this is just a small list, but vResource Viewer, this actually allows you to connect directly to the running device and see exactly how much resources are being used. So texture memory, which render targets are there, it prints out a log, and basically you can quickly see how much memory is being used for each asset. And there are different profile counters as well that you can enable and disable, and debug rendering and stuff like that too. vScene Viewer, so that you don't actually have to compile a project to see your thing running on the device. So you can create a scene and it deploys it to the device. For bitmap font generation, Visual Debugger, which I'm going to show you guys in a bit. It's a really cool tool that, again, you can connect directly to the device and get various statistics like where are my contact points, what kind of A-star queries are happening, and full profile counters as well. And a script debugger for Lua debugging. And rapid prototyping, we actually put a lot of effort into this because indie developers especially need to be able to create ideas really quickly and see that running on the device itself and then show whoever's managing them or whoever they're pitching to. So we added remote input as a way of allowing you to quickly prototype input controls. So what you can do is actually have your browser running, and any kind of input that you get, accelerometer input or touch input, is sent directly to the vForge editor. And then you can play it and modify it directly from inside the editor, so you don't have to constantly go back and forth. So it really improves iteration time for input control. We also have vFileServe, which allows you to hot swap assets. So you have your thing running on your device, and you maybe change a texture, you press one button, and it immediately shows up on the device itself. So that's, again, a really fast way for artists to see what they're doing, or programmers. Alright, so enough slides. Nobody likes PowerPoint, so let's go over to vForge here, and I'll give you guys a quick, uncomfortable demo here. Okay, so here we have vForge, and you can see on the left here, these are the layers that I kind of mentioned. So each of these layers actually has a lot of entities like lights, models, that sort of thing inside of them. And the idea that I said before, where you can have a lot of people editing things at the same time, you can right-click on a particular layer and say lock layer if this actually had a Perforce connection. And I'll actually do a Perforce checkout and a Perforce lock, so that only one person can be editing this layer at a time. And if you use the same paradigm, we actually separate it. There's a one-to-one correlation between the files on disk as well. So if you're using something like Git, if you have some sort of convention with your layers, multi-user editing becomes easy as well. So let me go ahead and play the game inside here. Actually, this is probably going to be pretty loud. It's down. Okay. No, way too loud. So I'm just going to play that sound. So here's the game running, and again, you guys can download this game on any store. It's called Anarchy RPG, and this is showing off our physics system, our animation studio, and everything all inside of the editor here. And there's even some enemy logic. We show off a bunch of particle effects, and it actually blends into ragdolls as well. So basically, and also, of course, there's UI, so you can see a mini map here. The idea with this demo is kind of our mega demo. We wanted to show all of our products running at once. So yes. So let me go ahead and show you guys kind of the process of creating things inside of the editor too. So I'm going to fly over here and bring up the asset manager. And this is basically your portal to see all the different assets that are available that you can drop into this scene here. So I'm looking at everything, and of course you can change thumbnail size, kind of what you would expect. And you can have different libraries. So in this case, RPG filters out just the custom assets that I created for RPG. I can filter it by static mesh, and you see we even generate thumbnails for static meshes. I'm going to come in here, I'm going to look for pillar, and I'm going to just drag and drop this pillar into the scene here. And you can see when I did that, it actually landed exactly on the ground because we actually do a raycast behind the scene so that the asset lands where you want it to land. So for instance, I could put this guy over here, yeah, and it lands exactly on the ground. And clearly you can see that this level is now way prettier than it was before. So if I come back over into the asset browser, so static meshes are things that are static, obviously. Models are things that can have things like bones or skinning information on top of it, or even vertex morphing, or morph targets, whatever you want to call it. So if we filter out to models here, I'm going to create a model that we can actually do a little bit more with. I'm going to come down here. Maybe I will grab a piece of rubble. Is there rubble in here? Oops. Great. Actually, there's one that I really like. Let me just go back a little bit. Yeah, I'm going to drop in this temple rock formation right here. So if I drop this guy in here and move him up, it's kind of a big guy here. Should we scale him down a little bit? Yeah. So if I go ahead and press play here, he just kind of hangs out in the air. Now, this is where components come into play here. What I want to do is be able to make him interact with the environment a little bit in a physically accurate way. So I'm going to select him, come over to components, and on the left side here you can see all the different components that I can throw on this guy. So what I'm going to do is throw on a Havok rigid body, and then if I press play again, you'll see this guy falls and he interacts correctly with the scene just like that. And you can integrate different other technologies as well. This is just us integrating all of our middleware into this tool. You can do the same thing. Actually, if you come over and look at the different plugins that we have here, you can see that we've integrated Fmod, there's the base vision engine, there's also a toolset, there's also this RPG plugin. And the RPG plugin added these 3 custom components that you can attach to entities. So that's one way you can add behavior to different entities in your scene. Another way is through entity classes. So you can actually create different entity classes. If you come over to properties, you see the entity class for this guy is currently set to base entity, which means he's stupid and does nothing interesting. So I'm going to change this to, and if you look up here, we have all these different entity classes. For instance, you can set an entity to an AI character, and by doing that, he'll automatically start navigating around the level and interacting correctly with it. What I'm going to do is create a floating entity, and the moment I do that, I actually have a bunch of entity properties that are made just for this particular thing. So if I go ahead and press play, you can see now he's kind of wobbling up and down a little bit. I can change this property, and you can see now it's wobbling up and down a little bit more. And if you're totally following me, then you're probably going to say, hey, I could just do this little oscillation effect in LewisScript, and you'd be totally right. However, we found after putting this on a bunch of different things, and they all have unique blending operations, that actually this is kind of a slow thing. So the C++ guys were like, well, let me just create a quick plugin for you, and then the designers were able to add that on the different entities. So going back to what I said with scripting, what I could do is just add a script component here, and then I could use Lua to just, on its think function, just update its position of the frame. But I don't want to do that. So let me go ahead and delete this. Another thing I want to show you is a thing called shape linking, and basically I'm just showing you guys some techniques that we have to empower designers. And the other thing that I want to show you is called shape linking. So if I select this, let me go ahead and move this guy up a little bit. No, not that guy. So basically, if I come over to shape linking here, you'll see that this guy has a blue line. It's probably a little bit hard to see, so I'm going to move him up a little bit. Yeah. So now you can see that there's this line connecting this trigger volume here and this guy over here. So if I select these two, you can see that there's 2 events that can happen, or 2 events that you can trigger on this guy, an on dead and a on spawn. So what I did is actually connect, if I click this guy here, I connected this guy's spawn to the trigger event. So just like that, if a character goes in and triggers the on enter event, then this guy is going to get spawned. And this is just one example of how you can use shape linking. You can do other things too, like if you have a particle effect and you have a collision volume of some kind, you can connect the particle effect to the collision volume, and then the particles are actually going to collide with that collision volume. So depending on what you want to do, this is just a way of creating some sort of relationship between multiple entities. Another thing you might want to do is be able to group a bunch of entities together and instance that throughout the world. And to do that, we have a thing known as prefabs. So if I come over here and select this prefab here, let me actually bring up this manipulator and just select this in the tree view. You can see this guy has a little different icon here. And if I have relevant operations and make this guy editable and come over here, you can see that there's 4 different entities clustered together to create this prefab. One is the mesh, which is the thing that you see. We also have a particle effect and a static light and a torch sound. So what a designer or artist rather can do is create a prefab and then send this to his artist friend and go, put these all over the place. It looks great, right? And then if I right click and say resave as prefab, then all of the torches in the world will all get updated. And this is great, you say, but the problem is, well, it could look super, super boring if they all look exactly the same. We thought of this as well. Perhaps somebody told us after we didn't do it, but what we added was a thing called instance parameters, and what we could do is bring open the prefab options here, and we added this exposed parameters collection. So if you bring this up, now you can see all the different parameters available inside of this prefab, and if you come down to FireTorch, I could, for example, expose this wind speed parameter, and by pressing OK now this torch is going to, each instance of this prefab can have a custom value of the wind speed. So if I come over here, I click per instance parameter, now the temple prop torch has a wind speed, and I can update this on a per prefab level. So that's kind of useful. Actually very, very useful. So I think that was the main stuff that I was going to show you guys in here. Oh, actually, let me switch over to another scene real quick. It's called Block Tower. This is another one of the samples that we have included in our set here. It's called Block Tower because the other name that you want to call this, we're not allowed to use. So if I go ahead and press play here, you'll see that now we have all these blocks kind of jiggling around, and I can actually pull these guys around. Obviously, we're a physics company, so our managing director said if there isn't physics in one of our demos, we failed as a company. So then we created this at the last minute. So here you go. It's a pretty simple, fun block tower demo. It looks kind of compelling, and you can actually play it on the device. It's actually really fun on a tablet, and there's even some camera controls. The cool thing is you can actually put this entire game together in about 15 minutes, and it's something I do quite a bit because it's something I demo more than I would like. And it's quite cool, and what's cool is that the entire thing is actually built entirely in Lua. So there's no C++ code here, all of this is with Lua. So if I come over here, and let me select the camera guy here, and come over to script, you can see that this is the Lua script that is driving the camera movement. So if you come down here, you can see that we're getting the camera's XY position, the mouse's XY position, and if we actually click on the location, then it will move it up and down. And VRSD, which I mentioned numerous times, is our script debugger. So let me just bring this guy up real quick. So if you've used any ID, which looking at you guys, I'm pretty sure you have, otherwise you wouldn't be here, is a pretty basic IDE. You can see all the different scripts that are available. We have a pickable script, a pickup script. The pickup script is actually attached to each of the blocks so that you can pick one up and actually drag it around. This is where we actually do we get the component, the rigid body component, and apply velocity to it. So this script is attached to every single block that you saw there. And what I can actually do is come over to camera here and even put in, say, a breakpoint, come over here, and then if all went well, which it did, amazingly, I can actually start stepping through this, and if you look on the bottom here, you can see all the global variables, the local variables inside of here. So it's extremely convenient, and you basically get what you would expect. And you can connect this to the running target as well, which is pretty useful. So the next thing I want to show you guys is asset transformation. I brought up the asset manager a second ago. I'm going to do that again. So if I come over to texture and filter it by block tower, what I want to do is modify this block's texture so that on iOS it looks way uglier for some reason, so that people buy the Android version more. I don't know, some reason, right? So what I want to do is change for just the iOS platform, make this texture look more ugly. So the idea is you can have different profiles. I have PC, DirectX 9, iOS, and Android available here. You can create new profiles. You can create an iOS ugly profile that just makes all the textures really low res or something like that. But what I want to do is bring up the properties for this guy. If I come down here, you'll see that we have a current template. It's compressed no alpha. I'm going to change this to custom, and then come down to iOS and change the downscale level to 3, which means it's going to really, really compress this guy. Do update transformation, transformation successful, come over to iOS, and then I can turn on preview mode. And give it a second. And now you can see that it's showing you exactly what it would look like on iOS, which is super, super ugly. So if I come back over to PC DirectX 9, give it a second, you can see the textures are now higher res. Another thing that's pretty cool that we added in this recent version is this will actually, when you use PVR, when you're previewing the textures for Android, that's what it would look like in the viewport here, because the PVR converter is actually a completely different format, so sometimes it compresses a little bit more than you would like, and maybe you want to tweak the parameters for it. So then we add this option, so what's displayed here is actually using the PVR, not just the same settings. So that was a mouthful. Okay, one other thing, let me just bring up the Asset Profile Manager real quick. So this is where you can add and create new profiles if you want. So for instance, I can come over here and create an iOS and say, okay, and now I've created a new profile, and I can go in here and say the default for this guy should actually be, for iOS, scale down all the things. So you can come in here and per asset type, actually change the transformation rules. So for instance, with models, I can actually create a transformation rule for, say, Android, and do a custom transformation rule, which allows me to just call any kind of executable. And what I could do in this case would be, say, I'm using Simpligon or something like that. Every time for iOS, it would actually run Simpligon on this particular asset and, run some reductions on it. Let me go ahead and unlock that. Thank you. Okay, so that's that. Let me come back over in here and show you guys a little bit more demos on the other products that we have, because that's all of them kind of integrated together, but there's a lot of power under the hood that's not really shown in those demos. Havok Physics, as I said, Assassin's Creed, Skyrim, Uncharted, like 400 games have used this physics engine, so it's a pretty proven physics engine at this point. It's a very robust, rigid body dynamic system and constraint solver, fully multi-threaded. We have ragdolls. Actually, I'm going to show you guys a demo here, because everybody loves ragdoll demos. No matter how jaded you are and how many demos you've seen, everybody loves these. It also gives me a chance to show you our visual debugger. So I'm going to bring these two up. So if I just tile these two together here, whoa. So it automatically connected these two together. So on the left here, this is the demo that we have, and I can drag these guys around, and you can see on the right it's updating automagically. So that's pretty cool that it's reading that. And again, this could be running on an iPad and you'd get the same results. That's pretty cool, but what's really cooler is that I can drag them in here and it sends the data back as well. So that's pretty rad. Another thing is that on the bottom here, it's actually capturing all profile information as well, so I can actually drill down in here. And we have things like an integrate, broad face job, narrow face job. So you're going to see a little bit of increase in the integrate here. So as I'm moving around, the counters are all updating. And these little arrows here are actually the individual contact points as well. I thought that was pretty cool. But what really blows my mind, and is very useful from my end, where I have to debug clients' problems all the time, is I can actually press record here, and I'm going to save a movie file called file of awesome. And as I start modifying these guys, so throwing these guys around, I'm just going to throw all of them off the thing. Go away. So now, maybe a performance problem happened. I'm going to go ahead and stop this. That just saved my file of awesome out. So if I reload file of awesome and come through here, I can actually drag forward and backward and drill down into each of these counters and see exactly how much time was taken at each of these individual frames, or maybe there was some sort of penetration that happened that I didn't want. So I can actually browse through this and look at exactly what's going on. So this is a very, very powerful tool. So ragdolls, pretty cool. Obviously we also have fast asynchronous raycast and linear cast, also known as shapecast. And we include extensions to the physics system, such as character controller, so you can quickly and easily have your characters interact with physical the world so they don't bounce and like penetrate walls and stuff like that. And we also have a vehicle kit, which is basically a starting point for you to create a game that actually has vehicles in it. So here we go. This is one of the demos that we have. And we have all sorts of different kinds of vehicles that you can look at, some more arcadey than others. And this one, which is my favorite, totally uncontrollable car, but really fun to play with, all the way up to super boring car, or semi-truck, rather. So as you can see, a lot of different varieties, and basically this is just to give you an idea of the types of vehicles that you can create. You can basically specify where the axle is and how many and so on, so creating your own vehicles of any kind is pretty simple to do. Vehicles, so that's Havok physics. You can find a lot of information on this, and actually before, many years ago, we started releasing the PC Access version of this, so it's already been free for PC for quite a while. So if you just want to use the physics system, you can grab that too. Havok AI, which is kind of a deceiving thing. We don't make entities automatically smarter. We create a pathfinding solution. So we take a 3D world that you have inside of the editor and generate a 2D nav mesh from it, so that characters can navigate around it using A* queries. So we have very fast multi-threaded nav mesh generation. Actually, some of our clients have done nav mesh generation at runtime as well in their games, because they have things like custom car tracks or something like that, so they generate nav meshes at runtime, which is pretty crazy. We also support dynamic cutting. So once you create your nav mesh, there will be situations where your world is going to change in some way. Maybe it's destructible, maybe there's a door that's programmable or something like that. So this is a quick example of what that would be like. So here we have dude, and he can navigate around. So let's have him jump over this, and there he goes. And what you see underneath here, actually the orange bit here, that's all the 2D nav mesh. If I start dragging this guy around, you can see that underneath it's actually cutting into the nav mesh, and it's very performant as well. So all it's really doing is adding edges. It's not actually cutting into the original geometry and fragmenting your memory or anything like that. And then we add in these user edges. And user edges are what we use to say, hey, this is something that you can climb on. Hey, this is a ladder or something like that. In this case, this is an area that you can jump over. So that's also very powerful. And then on top of that, because this is just for navigating around a 3D area, right? What we added was local steering. So it's basically character avoidance as well as avoiding dynamic obstacles. So in this case here, these guys have guys coming at them, and they're avoiding each other, as well as these dynamic obstacles that are coming through. And they're not just like running out of the way and maintaining the same velocity. They actually look ahead, and if they see something going and it has a velocity, then it might just slow down, because it'll be faster to just slow down and wait for a second and then keep going. So this is very highly tweakable and gives very realistic results and is performant. We have another demo that has 10,000 of these guys running around the scene. So there you go, Havok AI, quite a powerful tool. Then comes Havok Animation Studio, which actually comes with two things. Havok Animation, which is the runtime side of things, which includes our optimized animation blending system. There's a lot of platform-specific mathy optimization awesomeness in there. And it also includes our animation compression algorithms. We actually include 3 different kinds of animation compression, highly tested over many years. So that's the Havok Animation runtime side of things. And then the other side, we have the graphical altering tool, which we call HAT, or I like to say HAT, but Havok Animation Tool that allows you to create animation state machines. And from inside of here, you can do things like ragdoll blending, so going from running animation to a death animation or something like that. Animation syncing, foot IK, so that when you're walking upstairs, it doesn't penetrate the ground, because that's bad, and retargeting. So with ragdoll blending, I give the example of blending into something like death or something like that. But hit reactions is another good one. So what you're seeing here is actually a ragdoll. So this is all rigid bodies. And then every frame we apply forces so that it matches the animation as closely as possible. And when it turns red, it means it was simply not possible given the constraints to make it match the animation 100%. But it's pretty close. And then once we do this, we can apply things like him getting hit around, like getting dragged around, or my favorite, him getting a little gimpy. So with this way, it's really easy to still apply physical constraints onto something while still trying to match the animation. And then from here, I can then map this ragdoll's positions back to the high-res animation target and be able to animate my in-game character. Pretty cool. Retargeting. Retargeting is another very useful feature that a lot of people really like and want to use. And what this allows us to do is you see all these 5 characters here, and they actually all have very different bone counts. If you look at this, some have 93 bones, some have 64 bones, but they're all sharing the exact same animation. So we have a way of mapping from one set of bones to another set of bones. We have all sorts of heuristics for selecting what that is, so that all of these can share the same animation, but hey, it still looks really good. Some of them have ponytails, some of them have eye bones, all sorts of crazy stuff. Yeah, I quite like this demo. So, make your animators happy, use animation retargeting so they don't get really upset at you. So that's the runtime side of things. Now let me switch over into Hat and show you guys a little bit of what this tool can do. So here we are in Hat. On the left side here you can see the different characters, and you can actually have multiple characters. In the case of Skyrim, used animation tool extensively. In fact, their weapons, the different objects in the room, like chests and stuff like that, they all were different Havok characters, like animation characters in here. So they all had different state machines on top of them. And on the right here you can see the state machine, and you have going from locomotion and different transitions between each of these states. So transition that's leap and leap finished, go back to it. If I drill down in here, you can see we have different animation clips, like idle, idle to walk, walking, running. And as you transition between them, these will actually get highlighted. So let me go ahead and press play here. And as I go through here, you should be able to see that the states, the transitions get activated due to certain events that happen, and then it switches to a new state. And if I bring open a view here, I want to look at events. Yeah. So this is an event-driven state machine, right? So events happen, and then when you're in a new state, different events can be triggered. So in this case, you can see these are all the different events that I could trigger right now. I could, if I wanted to, trigger a draw sword event, and now he's drawn his sword, which is pretty cool. Now I'm going to put it back in there. It's dangerous to run with weapons. So then I'm going to come over here, and this seems kind of like a game. I mean, it's not Tomb Raider or anything like that, but it's pretty cool. And the cool thing for me is that all of this is actually done entirely in Lua. So it is possible to extend it in other ways, or you can send payloads to the game through events, or you can script this entirely inside of Lua. If I come over to here, you can see just some of the scripts that are available. This is actually quite a bit of logic to drive this. And usually it's logic that drives inside when you're transitioning between different states. And this is actually a fully integrated Lua debugger in here as well, so you can set breakpoints just inside of this editor too. Another cool feature that we have is called docking. So let me actually, for some reason Havok really likes to do this, primarily because we've debugged so many client issues before. But I can also record directly inside of this editor as well. I'm going to go ahead and turn on a docking viewer here, and then go ahead and start recording. So I'm going to start running over here. I want to showcase a docking example. This is also an opportunity to show everyone that's watching me how amazing I am at video games. So I'm going to come over here and jump over this really awesome spot. It's pretty much the only place I can demo this effectively. So you have to watch me do this. I've messed this up a few times. It's probably the most embarrassing thing you can do. So there we go. So now I'm going to go ahead and stop this. This also gives me a chance to introduce you guys to the timeline view. Like all of our things, you can scroll this forward and backward as well. So if I come over here, you can see, awesome. And if I come up here, so on the very top, these are user-raised events. And this is how you would communicate with your runtime game with the behavior graph. Because what this tool outputs is a behavior graph file, which says where the states are, what the transitions do, that sort of thing. And if you want your game to make the state machine do things and generate new animations, you send the graph events. So in this case, you can see these are all the different user-generated events. In this case, I tied these buttons and these controllers to two different events. So as I scroll back and forth, these are the events. Then down here, you can see all the different animation clips that are happening. So one thing that I want to point out here is you see these little circly things that say foot up and foot down. These are called sync points, and what the animator, or you can automatically generate them, is sync points like a left foot down and a right foot down. And then if you put that in your walk animation and your run animation, then our system will automatically, when it's blending between those two animations, make sure that those two sync points are aligned. Why is this awesome? This is awesome so that you don't get foot sliding. If you didn't care at all and just blended between two animations, it would just go wonka, 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 and this is bad. So with this system, and then also we support non-synchronized, so it can be left foot down, right foot down, left foot down, left foot down, right foot down in the case of some sort of limp or something like that. So it's pretty advanced. But I got distracted. What I was really showing you is docking, right? That's what I was doing. So let me come over here. Yeah, look at that, good jump. All right, so come back over here. Wow, that's so long. Taking a while. Okay. So let me switch the camera back over to orbit so you can get an action shot of this. I said action shot. Okay, or maybe not. So what I'm going to do is come over to here, and as he jumps, oh man, this is going to be really difficult to actually do this. Okay, here we go. Okay, so action shot of this amazing jump that happened. So if this animation just let itself run the way it normally would, it would actually land at this point here. So what our system does is say, hey, I actually want this animation that I'm currently playing to land at exactly this point. And what our system does is it scales out the animation and makes it, and slowly interpolates it so that you can see this error percentage here. As I scroll through, it's slowly landing to exactly that point. So in this way, all of your ramps and stuff like that don't always have to be 100% aligned. You can scale it out, scale it in. Again, you want your animators to be happy, and so do I. So this is another way that you can do that. Another thing that we support is actually remote connection. This is pretty much what you would expect. You can actually connect this directly to your iPad, and then it just works. And then you can actually see the same state transitions that you saw a second ago. So let me go ahead and switch back. Actually, while this is opening, bring that up. So that's the Animation Studio. That supports remote debugging. And a few other things on the Vision SDK as a whole. All the source code that we provide in the SDK, I maintain on GitHub as well. So between releases, we try to keep our major releases short, but sometimes people find bugs. If the community finds bugs, we want to push those out quickly. GitHub, great way to do it. So you can go to Project Anarchy, and get the source code there. You still need to install the SDK because we don't include all the assets on GitHub, because that would be totally insane. I mentioned at the very beginning we do support FBX now, and in the spirit of anarchy, it's all open source, and we want people to look at the code and scrutinize it and tell us if you find bugs. I also put up a binary version of it as well. So basically it converts FBX files to Havok scene file formats, called tag files for some reason. So you can just drag and drop in the executable, and it gives you the files that you need. And we're also working on a Blender export plugin. Blender already supports FBX, you can already get stuff out of Blender, but we just want to make it a little bit easier because we know a lot of indie dudes really like their Blender, so we want to make it good for them. Also working on a 2D toolset, and we're going to be releasing that on GitHub as well. It basically simplifies the creation of 2D prototypes, and I'm saying prototypes here, but if you wanted to use it in your real game, totally could too. We're trying to make an optimized rendering framework for that. So basically, it's not majorly complicated. What it does is give you a sprite entity, give you collision callbacks that can happen inside of Lua, move your sprites around, that sort of thing, attach particle effects to it. Now the big news for you guys who haven't heard this, we had just launched a game dev challenge. What was it? Actually, I think it was 2 days ago. Lots going on. The top winner will get $100,000, and that's actual cash monies. That's not hidden with us giving you licenses to stuff. It's actual cash monies. So check this out. The deadline for this is May 31st, 2014. Go to our website or register now at projectanarchy.com/contest. So please do check this out. We have like kind of a sub-contest thing that's going on with this too. If you create an awesome game for GDC, you get extra monies. It's like we're just giving money away. So you might as well at least check it out and see what you can do with this. And one thing before I close and leave it open for questions, 2 things that we introduced recently. One, I'll quickly show you kind of one of the demos that we've created for the 2D toolset, and it's really cute. So something simple. I can't die yet, but they can explode. the idea is all of this is done inside of Lua, and it should be very few lines of code to create something like this. And you just drag and drop assets in here, and you can use sprite sheets, full animation, set the states, that sort of thing. And we're putting emphasis on the rendering side of things too, because 2D toolsets can be pretty render bound sometimes. So that's the 2D side of things, and we also introduced a package tool in the last version. If you don't know, we released our 2013.2 release yesterday. So now that's just out, and we also include this package tool. One of the big complaints that people have is, hey, over-the-air size is super important. I want to make sure it's less than 50 megs or whatever it's changed to now. And it's just always smaller is better. So we attach this package tool, which basically reads the project and says, these are all the things that I'm going to include. In some places in your project directory, you have things that you don't really need. So you can just click uncheck, and then it unchecks it, it doesn't include it anymore. And then you can say export, and from here, you get this other dialog, and you can choose which profile you want, and it'll show you the uncompressed size, and after you compress it, show you what the final package size is as well. So it's a really convenient way to quickly iterate on getting your package size down as much as possible, and see exactly which assets are really being used. Now I'm really done, I promise you. So I'm going to leave it open to some questions. We have a few minutes. Yes?
Do you support the APK extension files when things get too big?
APK extension, like how big? I actually don't know what that is.
So you can package up to like 2 files, 2 gigabytes each, like,
okay.
Because I don't know whatever the limit is for like just a single APK. Like yes, do that.
I've never created a package more than 2 gigs, so I don't know the answer to that question, but I will definitely look into it. That is a very good question. That's the first person that's asked me that. Any other questions? Yes.
So, how are you guys managing the UI system? I mean, for instance, from a experience, one thing that you have to do is basically create like triple checks to make sure that you're clicking on UI or not, to say clicking on the floor of your simulation. So, do you guys have any system?
Yeah. So we have a number of ways to do this. In Lua, we have the thing called pick entity, which tells you if you're actually sitting on the ground, for example. Another thing that we have is actually free. If you've ever heard of Scaleform, it's Autodesk Scaleform, which is a full UI system. So in the last version, you can use Scaleform completely for free now. So if you want to do GUI stuff using Flash, that's completely available. And you can do callbacks between C++ and Flash and Lua and Flash. And we also have a separate GUI system as well that's XML based if you want to define your GUI in that way. So we provide a number of options for people. Yes?
Yeah.
That's fine.
So, like, also, I saw that, so basically, if I understand correctly, the way that you guys handle coding is you can kind of inherit from the main class, or let's say a game object, and then that is the C++ file of the code. And then if you want to add, say behaviors to that, you do them in Lua. Is there a possibility to actually kind of create behaviors in C++ and add them, or?
Yeah. So the physics plugin that I showed, where I added a component that was a Havok rigid body,
right.
That's a component that was created in C++. So you can do the exact same thing. All of those components were actually created in C++. Yeah.
How easy is it to integrate with external APIs like Flurry, Google in-app purchase, and that sort of thing?
Yeah, we're actually creating a couple samples to show people how to do this now, but it's really not that difficult. I mean, I think having an example out there will make it easier for people, but the community supports this side of things really well. I mean, usually there's a C++ layer, or in some cases maybe like with Google Play, there's a Java layer, and we have methods to communicate between the unmanaged C++ layer and Java, so it's pretty easy to create that connection. Yeah.
I'm sorry.
No, it's fine.
Keep asking.
No.
So one of the main issues in Android is basically the different sizes of the screens. How do you guys manage the?
Yeah, so we actually have a thing called variant keys. So if I actually bring up this guy, and then this guy. So we have this variant key set editor. So one of the things you can do is like the add 2x thing. So then based off that key, it also ties into our asset management. So depending on the resolution that you use, it can automatically switch between the high-res version or the low-res version.
And for the screen size, basically, like, so So basically, you have to determine screen size from the very beginning of the application. Do you get like one for each one of the screens that we create, or do you have?
Well, I mean, with Scaleform, that makes it considerably easier. So if you're doing GUI type stuff and you're dealing with a lot of different aspect ratios, then using Scaleform or something like that, you can attach logic to make sure that it goes to the correct one, right? You can also have things like attach to the left side of the screen or the right side of the screen, and then it automatically updates the UI elements. Yeah?
I have used neither like the Havok tools nor Unity. What is like the 30-second pitch?
So as someone who has shipped games with Unity before at my last company, so I have had a lot of experience with Unity, and really the biggest improvement, they're both great products. The one thing that's really nice about this engine is that one, it's C++ access, which means if I run into any performance problems, I don't run into the wall of running behind an interpreted language and not being able to have low-level access. Our API is genuinely open, so even though we don't provide all the low-level source code so that you can replicate this engine, we do provide all the headers, so all the information you need, like the render targets, the shaders, like all of that is very easily accessible and quick. You don't have to swap between an unmanaged and managed layer, because that cost can actually get really high in something like C#. So that's a huge, huge win. Another huge win is we've actually been around for about 15 years, and our tool sets, and we have over 500 titles shipped with our stuff, so things like Animation Studio has been used by AAA studios for many, many years now, which means it's very, very feature rich. So at the surface, a lot of our competitors kind of look the same, but when you start to dig in and you start to develop your game, you run into missing features or pieces that aren't there that you have to implement on your own. Obviously, there's stuff that I'm sure we don't implement as well, but given the experience that we've had, we know how to handle those and have a really fast turnaround in case it's something the community and our clients really, really need. Yeah?
What about targeting for web?
So currently we actually used to support a web plugin. Currently we are not supporting web, but that's something that we're highly considering putting on our roadmap, depending on how much feedback we get back from the community. Actually, it's been surprisingly less than I would have expected if you look at our idea section. So if you guys feel like that's something that's really great, please vote for that on the idea section. Part of my job is to make sure that the community is happy, which means I need to fight for things to get on the roadmap. So I need fuel to do that because there's limited engineering resources and time. So please voice that on the forums in our community. Yeah.
So while you don't support web, you do support the various desktop platforms, though, right?
Correct.
So
Yeah.
you can ship a native app instead.
Yeah, you can. The PC platform, deploying to PC is not part of the free package. That's part of the upgrade package. But yes, we do support other platforms as well, like 360 and PS3 and Vita and that sort of thing. So if you wanted to deploy to other things, our goal obviously is you make lots of money on the mobile side. Maybe if you wanted to deploy to other platforms, you have the option to do that. Yeah.
You don't support OS X and Linux because of DirectX, or?
I'm sorry. Support targeting Mac.
Yeah, Mac. And
Oh, okay. So yeah, we currently don't have a Mac target, and honestly, it's only because of time and people not asking for it hard enough. Like, we have had a couple people say it, but supporting and maintaining a new platform takes a lot of work, and unless people want it, it doesn't really make sense for us to put in all that engineering effort just to have nobody use it. So again, it's one of those things where if you guys think it's great, push for it, and we'll try to get it on our roadmap. But I mean, we already do have our shaders are all generated in DirectX, so it's all HLSL, and we have a backend that converts HLSL to GLSL. So we already have an OpenGL ES 2.0 rendering backend, so converting that over to something that would work on Mac. I'm not saying it's trivial, but I'm saying it's not a crap ton of work. So it is totally a feasible thing to do.
Actually, yeah, that's probably the question is that. So, what kind of share level are we looking at? Like, suppose 3.0 maybe? Or?
Yeah, so what we're shipping with currently is OpenGL 2.0. We have the version that you see in here was all DirectX 9 because DirectX 9 and ES2 are pretty close. We have a DirectX 11 version with a full deferred shading model as well, but that's our pro side licensing. Yeah. I mean, again, it's not that we won't be supporting OpenGL ES 3.0. It's not like this is the only place the product is going. As the market changes and as more 3.0 devices come out, we'll definitely be adding that, implementing that as well. Yeah.
All the tools that you showed today are free for mobile, or is
Yes, I mean, they run on PC, but all the tools and the runtime all work on mobile completely for free. And you can deploy, and there's no hidden revenue cost. If you make $1 billion, which I hope to God you do, that's awesome, you get all of that money. There's no revenue capping whatsoever.
So your dev environment is only Windows, or is it Mac too? Or?
Yeah, our dev environment is only Windows. We have when you go to projectanarchy.com/download, which I hope all of you do, I'm just going to bring this up here. Go to projectanarchy.com/download. There's going to be two options available. One's for Windows and one's for Mac. And the Mac option is only when you want to deploy onto Mac. So we include some Xcode template project files and stuff like that, and a few tools to help you if you wanted to run vFileServe, which is the tool that lets you serve files from the Mac directly to your device. That actually runs on the Mac as well. But that's really the only tool that runs on the Mac. Everything else runs on the PC. So I've had this question a few times. My answer is usually, hey, you can update textures and stuff on the Mac, and then if you want to work on the PC, on the level editor side of things, you can do that. But I also have been questioned, is it possible to create a game entirely from C++ and just use the engine that way? The answer is most definitely. If you want to create everything in code and create some sort of generative game on just Xcode, go for it. Sounds awesome. You don't have to use the editor if you don't want to. That was slight sarcasm on the awesome part. I really like using the editor, but it's totally possible if you want to create something entirely in code. That is definitely something you can do. I think we're out of time. Thank you guys very much for sticking around. Have a good one.